So I'm a physicist, and actually, as a physicist, this kind of problem is very near and dear to my heart. We're talking about a particle that moves along at some kind of weird, style of motion, or maybe let's not call it a particle. That's just kind of weird. Like, let's say this is the arm of a grandfather clock or something like that, and this is the equation that governs its position at any given time, and it's swinging back and forth like this. And so you would expect that the uh, place that it is in any given time is some function that has to do with trig functions, because that's what trig functions have to deal with, is they deal with this kind of repetitive motion. And so if this is the position as given by s of t, then in order to figure out the acceleration, that's actually pretty straightforward. All you do is you take the second derivative. Now, there's an intermediate step, because I'm not good enough to just kind of jump straight to a second derivative. So I like to always take the first derivative to kind of do the middle step and then take the second derivative. Let me tell you what I mean. I'm going to take the ds dt, and I'm going to call this a new name. I'm going to call this v of t. Now this part right here isn't necessarily required for math, because this is so that you understand, actually this is just the velocity as a function of time. And taking the derivative of a sine function, you get cosine of t. So I've got cosine of t. I still have that 4 out there. And then over here, the derivative of a cosine is negative sine of 2t. And I need to make sure that I pop out that 2. That would be the chain rule. You take the derivative of the cosine of 2t, and then you take the derivative of whatever's inside. So let me the dust needs to settle. Let me just kind of write things out. Cosine of t plus 2 sine of 2t. Now that's my velocity as a function of time, or my first derivative. So let me take the second derivative if I want to get the acceleration as a function of time. Again, the second derivative is d squared s over dt squared. That's just how you write the second derivative. And we're taking the derivative of this. So this would be 4 times negative sine of t plus 2 times the cosine of 2t times 2 again. Yep, that's the derivative. Good. Okay, so I think I'm going to try to do something like 4 times cosine of 2t minus sine of t. Yes, that's correct. So notice how I wrote this as kind of 3 different ways. I wrote this as s double prime. I don't really like this double prime notation. I am actually a big fan of this one. And not everyone's is a big fan of that, especially when you're first learning. But it's it tells you, obviously, the function is a function of t, and that's what I'm taking the derivative with respect to. The a of t, that's a physics thing. Obviously, that stands for acceleration, since it's the second derivative. And that's it. Yeah, we can keep taking the derivative of this thing, and it won't actually die out, because there's trig functions involved. And the triple prime, just this is kind of a physics note, is the triple prime is, all right, the original function was called the position, and then the first derivative is the velocity, and the second derivative is the acceleration. The third derivative is actually given a name, and it's called the jerk.